right, it looks like it's working now, so let us know in Piazza if it is not. Okay, I'm getting good reception now. So anyway, back from the top here. Today we're going to start on lists and list-based data structures. That includes stacks and queues, which you may be familiar with a little bit. But our first motivation is to look at an array-based queue. Our motivation is that dynamic data structures are much better than plain old arrays. Right? In Java, for example, if you had to use an array, you would have to specify its size. Then you'd have to create it, and C, this is even more arduous because you have to set up memory for it, and then you have to cast it, and then you have to do memory management. At least with Java, we don't have to worry about that memory management. But we still have to create it. Once it's created, this numbers array will only ever be able to hold at most 10 things. Even if we only have 3 in there, then there's 7 slots that are being wasted. We can never put 11 elements in there. We need a bigger array. It doesn't grow, it doesn't shrink, it's not dynamic at all, right? And so the solution is to use a dynamic list data structure. And the dynamic list data structure simply is that it's going to allows you to grow and shrink automatically, right? And you don't have to worry about those details. You can add things without worrying about the details, right? This is an object-oriented programming principle. Abstraction, encapsulation. We don't have to worry about the details because those are abstracted away from us. How is this list working? I don't care. I just want to put stuff in, take stuff out. Do I have to expand the array, the underlying array, before I do that? No, that would be a leaky abstraction, right? I don't want to have to worry about those details, so I'm going to go ahead and apply and leverage object-oriented programming principles. In fact, all 3 of these, encapsulation, abstraction, and polymorphism, to create a dynamically growing list. So here's my first attempt, right? I've created a class here called myList. Over here in the demonstration class, I've created an empty list, right? If I've got to start adding stuff. So let's go ahead and start designing this thing. If it's going to be an array-based list, then inside this class, we will have an array to support that. So it's going to look something like this. It's just going to be abstracted away from the outside world. So we'll have a private integer array. Underline. I could call this an underline array, but I'm just going to leave it as an array. In fact, I'm going to even shorten it up to ARR. Right? A is a little bit too short, but ARR, oh, I know what that is. That's an array. If you want to come back and call it underlying array, go ahead. But I'm going to go ahead and leave it as ARR for now. Right? So I'm going to create that default constructor, public myList, and the default behavior here is to simply create an array that can hold things. How big of an array should we create initially? Well, if we create one that's size 0, then we can't add anything to it immediately, right? So let's just go ahead and create it of size, I don't know, 10. This dot array is equal to new integer array of size 10. Right? Initially, this will be able to hold up to 10 elements. Right? How many does it hold, though, right now? Have I put anything in after calling this constructor over here in the demo? No, it's an empty array. It's an empty list. So I would come back and make sure that I to do documentation. This creates an empty list, right? But it has an initial capacity of 10. Nothing's in there yet. We haven't put anything in there, but it has a capacity for up to 10 elements. Well, with any data structure, just like a table, you need a way to put stuff in, take stuff out, modify stuff, update stuff, right? The basic CRUD. So with respect to CRUD, we'll want at least a subset initially of those of that capability. We want a way to add things, right? Maybe we want a way to remove things. Right? We want a way to retrieve things. And we want a way to maybe modify things, right? That I put 10 in there. Oops, sorry. Change that 10 to a 15 instead, right? I'm only going to demonstrate a few of these things. Well, we need a way to get stuff in. We need a way to get stuff out. If you want a way to remove things or modify things, then that's going to be pretty easy once we know how to do these other things. Okay. So my first attempt at putting stuff in, right? I'll have a public method, and it's not going to give you anything back. You're giving something to the list. I'm the list now. You give me an integer 10 to put into the list. Right? Where do you want to put it? Well, for now, let's just go ahead and add to end. Right? And this is the thing that you want me to put into the list. You're giving me X. I'm the list. Thank you. I'll go ahead and take care of that for you. Remember, abstraction and encapsulation. We don't have to worry about those mundane details. But now, we are the class. We're inside the class, and we do have to worry about those mundane details. Where can I add it?